Hey class, I'm hoping you can have a good day today, productive, even though I'm not here. Let's make sure you take some good notes here and get the main idea of what we're doing, okay? We're going to start with number 2. What you see on this page are referred to as rational expressions. They have a fraction, in other words, that they're equal to. I want you to look at number 2 because they're asking us to simplify. Okay, so factoring can help a lot. This first one, I can factor out a 6. And then you can see what happens. Because I'm multiplying 6 times this quantity, I can go ahead and reduce it out. Cancel it, in other words, and I get the final answer of just 6. A lot of these are factorable. And for example, let's look at number 3. We can simplify number 3. The bottom can be factored a little. The top, I think that's going to stay put. So we have to factor a negative 48 and have it be close to being able to make a 2. So I know that's going to be 6 and 8, but be careful of the signs. Yes, the 8 has to be plus 8 in order for the factoring to be true. And now you see it, but I got nothing left up there. What's left up there? Well, y plus 8 cancels out y plus 8 and creates a 1. So my final answer can be 1 over y minus 6. Pretty cool, huh? Pretty easy. Why don't you try number 4, pause the video, and then we'll come back and compare. Pause now. All right, did you factor correctly? Did you cancel out the r plus 4 quantity? See, we're multiplying these quantities. We can just do a 1-to-1 cancel. And 2 over 8, that can even be reduced to 1/4. So our final answer here is just going to be 1 times r minus 5. That's r minus 5. And there's a 4 down here. There it is. A very nice simplified fraction. In number 5, you see something that's going to help us quite a bit. There's a little pattern that comes into play. See, a minus b is not the same as b minus a. Think about it. They're not the same. But this works out kind of cool. If you ever get a subtraction that's a reverse subtraction on the other side of the fraction bar, believe it or not, they all will equal -1. So that's going to happen in number 5. In number 5, we factor the best we can, and it happens. It happens. We get a subtraction that's not quite the same as the other subtraction. And instead of being out of luck, we can cancel out as long as we put a -1 times the bottom or times the top. I'm just going to put it right here. So the result of that is a -1 times p plus 7. When I distribute that, it's just going to look like this. Done. So not too bad, is it? Now we can work with a lot of these and try a lot of these out, but the reason we're doing some of this is because I want you to get to the point where you can multiply and divide. And it does look tricky. It looks difficult, but it's not nearly as difficult as you might think it is. Okay, we can actually do 9 and 10 right now. And there's a lot of choices that you can make here. Like, do you want to reduce 10 over 18? You can. 6 over 2? You can. Y to the third over y squared? You can. Some people just go to multiply straight across, though, and simplify the multiplication first. So if I did that, take a look at what I would get. Using my exponent rules, I get the following fraction. Now I can use some more exponent rules and simplify. Let's see, 60 over 36, cut it in half, 30 over 18, that's 15 over 9. 15 over 9 is 5 over 3. So I can reduce that and then go to town on my exponent rules. 5 minus 2, put the result on the top, 7 minus 4, and there we are. Now if I write this a little prettier, it would look like this. Okay, a nice fraction. Piece of cake for us. Now 11 and 12, when we do these, they're just like the simplifying that we've already done. Instead of simplifying first, let's factor everything and then do the one-to-one reducing. So try to factor number 11 right now and then check back and see if you factored it right. Then we'll simplify it together. Pause right now. So if you notice here, we have lots of multiplication going on with groupings. All right, so let's do the reducing if possible. Here's one. Here's an x minus 1 and another x minus 1. Here's an x plus 3 on the bottom and an x plus 3 on the top. We can cancel that as well. I see a 4x over a 4x. That's equal to 1. We don't write the 1 because there's understood to be a 1 if you ever cancel anything out completely. Look at what we have left. X minus 2 and 2 times x plus 2. I think that's going to be our answer. X minus 2 on top, and then we can just keep it as 2 times x plus 2 on the bottom. If you want to say 2x plus 4, go right ahead, but I think this is nice and simple. It's too bad we can't cancel out the x's, because that would be nice, but because it's subtraction with this x and not multiplication with both of them, we can't do any one-to-one canceling. That is our answer for number 11. All right, let's do number 12 and then come back and check. Hit pause right now and try number 12. All right, I hope you factored everything okay. Let's see what we can do with number 12. Aha, the v minus 9, the other v minus 9. This v alone cancels out this v alone. Do you see a v plus 1 anywhere down here? Oh, the 5 and the 15. The 5 goes into 5 and the 5 goes into 15. Ah, the backwards subtraction. Yes, we can cancel these, just not equal to 1. It's not like they go away. When they're backwards, you need to put a negative 1 somewhere. So when I cancel these out, I leave a negative 1 here, or I can even just put a negative up here with this negative 1. I could also put a negative 1 up here. Somewhere, I have to put that negative 1. Okay, I think I'm just going to do this. Put that negative 1 right there. So now I have a negative 1 times v plus 1 left on the top. On the bottom, I've got nothing but 3. I don't think I have another 3 anywhere. So I think my best answer, I can go ahead and distribute if I want to. I think I'll end up just like this. Okay, so take a look at it. See what you think. I'm feeling sassy. I'm feeling good. Now, division is just as easy. There's only one thing you have to do. Why don't we look at number 14? In number 14, we need to go ahead and factor, but also remember, you've got to flip the divisor. This one, the divisor, the second one, the one that comes after the division sign. So I'm going to go ahead and factor the best that I can here, but I'm going to multiply by the reciprocal. I'm going to flip it. And here's what it looks like factored and flipped. So I'm looking at this. I have factored the denominator, put it up on the top. So we're ready to multiply now. So we're not going to divide by dividing. We're going to divide by multiplying by the reciprocal. So let's see what I can do. Oh, a little one-to-one reducing. Oh, yeah. Let's see. 2 goes into 2 once. 2 goes into 10 5 times. Let's see what's left. 5. There's nothing else with the 5. That's going to be on top. There's a 4 and times a 1. What else do I have? Well, I think I have this little x right here. So I have a 4 times this x. I'd never canceled this x out. So it looks to me like we have this beautiful, I know it's ugly, fraction. Okay? So now I would like for you to try number 15 and just see how you do. I know it's a lot of factoring, but factor number 15 and come back. All right, we are back. Hopefully, when you factored, you got something like this. Notice I've flipped my divisor. That's why a minus 3 and a minus 5, the factoring for the denominator, is now on top. The factoring for the numerator, now on the bottom. So I can multiply straight across, and I see some canceling I can do. I notice something here. This 3 minus a on the bottom is just like a minus 3. So with the backwards, when you cancel them out, you put a -1 somewhere. I'll just put it right here in the beginning. I could also just put a -1 right here, whatever I want to do. Now, does anybody see anything else that I can cancel out here? Ah, the constants here. Look at 2 and 8. And a squared and a squared. So the a squareds cancel out. Okay, what is -2 over 8? That would be a -1/4, right? And I have this nice little grouping left on the bottom and a grouping left on the top. Looking good. So I think this is a good answer, but some people may disagree and say, hey, why don't you distribute that -1 and keep the other factoring? The reason they do that is so that you can see what values can't be used for a. So you can keep this like this. You could even just have a negative sign in front of this and leave it factored as much as you can. All right? Now, just for number 16, I know some of you are into this, so just in case you get a problem like number 16, watch what I do with that division. See that 4k plus 1? I flipped it. The next one is a multiplication, so I don't need to flip it. But take a look at the factoring. It's a difference of squares up there. So now, as I simplify this bubby, take a look. 4k plus 1, 4k plus 1, k plus 3, k plus 3. So it looks like all I have is 1 times 4k minus 1. That's 4k minus 1. And the bottom is simply k. Okay, now your assignments out of a textbook that I have scanned for you, give it your best effort. Make me proud. Use these notes to help you. I'll see you soon.